This is 18.2 and it's about parabolas. We've talked about parabolas and how they can change, like if you have the basic parabola, y equals x squared. That's what that one looks like. And then, that's a 2. If I said y equals 2x squared, we know that that gets skinnier. So that one would look, I should probably change colors. So this one would look, oops, I should have come down in the same spot. So this one would look narrower. And then if I have y equals 1/2 x squared, that one should look wider. And that was the last section. So the shape kind of changes. It's either skinnier, narrower, or wider than the basic y equals x squared. Now we're going to talk about what makes a parabola move right and left and up and down. The shape's not going to change, but it's actually going to move in the coordinate system. So this is out of the textbook, the 18.21 visual there. So it's a little bit confusing when you first look at it, so let me kind of talk about it separately. So if I have y equals x squared, and I'm just going to freehand these, that's going to basically look like this. Okay, and that's what they're showing you. I probably should have done that in blue. That's what they're showing you here in blue. Okay. If I have y equals x squared plus 1, that's right here in pink, and that's going to move up 1 unit. So if I put some units on here, and I'm not very good at drawing this freehand, but it's going to move up 1 unit. So it's the same basic shape. This almost looks like it's narrower, but it's not. If I took a transparency, if I took something see-through and I graphed both of these on 2 different see-through pieces of paper and I moved the purple one up, it would totally trace the red one. So don't think that these are becoming narrower or wider. It's just that it's farther up on the plane, and so it kind of looks like it's narrower. Okay, so now if I took y equals x squared, we'll use the book ones, minus 2, I think they use that one, yeah, down here in green, that one's going to move down 2 units. So if I put some units back on there, and I probably should have done that in a different color, darn it. Then it's going to come down here 2 units. So you can see that I always remember it because that's a minus 2, so it drops 2. This is a plus 1, so it rises 1. So these are called, sorry, doing this at school before the day, these are called translations. Translations are slides. So they don't, the shape doesn't change, it just slides up and down. So see if you can answer this. If I take, I should probably use f of x because I think they do in the book. If I take f of x, x squared minus 5, where would that shift to? Where would it slide? They call it a shift in the textbook too. Okay, you should have said down 5 units. You got to be specific. They're going to ask you this. If I took what you knew about last section and I said 2x squared minus 5, and I said what would happen to that? What's the transformation? Okay, transformation is just how does it change. Translation is how it slides. If I asked you what was the transformation, you would say it got narrower, and you can tell that by the 2. Okay, and it also slides down 5 units, and you can tell that by the minus 5. So what if I said f of x equals 1/3 x squared plus 7? You would say it gets wider. and it goes up 7 units. And when we say it goes up 7 units, they're asking you, I should probably say all of these, they're asking you to compare from the y equals x squared form. Okay? Later in other classes they'll ask you to compare from different forms, but every time we're comparing right now, it is from the y equals x squared form. And if you remember what y equals x squared looks like, the vertex is at 0, 0. And so when you say it slides down 5 units like on this first one, that means that the vertex is now 0, vertex, 5. Negative 5, sorry, because it went down. On this one, the vertex was still that, but on this one right here, the vertex was 0, 7, because it went up 7. So they're going to ask you, I probably should have put those in there, they're going to ask you where the vertex is. They're always referring to the original where the vertex was 0, 0. So, oops, let me put in figure 1822. Okay, well now I've got figure 1821 again and I can't get it out, and so just skip a slide. Apparently I don't have figure 1822, so I'm just going to fake it here. So now if we talk about horizontal shifts, and if you want to open up the textbook or look at it, it's 1822, the figure, but I'll kind of freehand it. Okay. If we have the normal y equals x squared, what's going to make it shift right and left? Let's put some things on here. If this shifts twice, and I didn't draw that perfect, but say that that's the same shape. If that shifts twice to the right, that is y equals x minus 2 squared. Now this becomes a little bit tricky because I always forget it shifts to the right. It's minus 2, but it shifts to the right. Okay? And if I shift it left, let's say 3 units, so let's put it over here. If I shift it 3 units to the left, that's y equals x plus 3 squared. So when your function is written in this form, this tells you how many it shifted, but it's always opposite of what you think. Like, this is a positive 3. You just got to remember that's left. It's always backwards of what you think. Now the book does a pretty good job of showing you, proving to you why it's doing that. It has you draw a table, make a table, and run values through your x. Okay, so you can always do that to figure out, well, why is it doing that? Which way will it go? If you forget and you're on a test, there's no reason you can't just quickly make an XY table and start graphing some points, and you'll quickly see if it's on the right side of the axes or the left side, and then you can go from there. So, I would suggest memorizing it, but if you forget it, which things happen, especially when you're when you're nervous, don't forget if they're asking you something about a graph, you can always make a table and graph it. And it doesn't have to be the perfect graph. You can just do a couple points just to get the gist of it. So test yourself out. If I wrote y equals x minus 7 squared, would that shift up, down, right, or left? And how many? And you should have said it would shift right 7 units. So kind of try to imagine what the vertex becomes, because they will ask you that too. Imagine it shifting to the right 7 units. It didn't shift up or down, it shifted to the right. So your x is what's changing. So your x became positive 7, your y still stays 0. Okay? And you can, you can always fake it. That should go on to, that should have come all the way down, sorry. 3, 4, 5, 6, 7. Draw it, fake it, and then go, oh yeah, that's 0, or that's, and I just made a mistake, 7, 0. Okay? Because it's easy to get those mixed up, and they're going to ask you that. On a multiple choice, they will have 0, 7, and 7, 0, so don't let it fool you. Okay? I'm going to put these two right next to each other. Why did I write f of x, y equals? Wow. This is what I get for doing it in the morning. F of x equals x squared minus 7. Notice the difference between these two. And it's just going to take a lot of going over a bunch of problems. Try not to use your notes the whole time. Try to start doing it without the notes. I know the book has this nice, neat little summarized table that's kind of like a cheater chart, but that's going to be dangerous if you keep using that because they won't let you use it in 2 weeks on the final. So, try to guess in your mind which way it's going to go, and then if you want to check in your notes, that's fine. So this one, we learned, goes down 7 units. And again, the hardest part is that this is a minus 7, so of course you go, oh yeah, down. But this is a minus 7 too, and it goes to the positive right side. And so you're just going to have to get that straight in your head. So this one would be down here. Okay. Again, the book has a table that looks something like this. These never helped me when I took math because I need to have numbers in there. But I'm going to draw it up here because it is kind of a nice, neat table to kind of summarize it if you're confused. Also, before I forget, 18.2 also goes over completing the square in the textbook. You don't need that. So these two types, this one, whoops, shifts right, that's a B, by K units. This one shifts left by K units. This one shifts up. And I just did all that backwards, didn't I? I hope you noticed that. Sorry about that. This one shifts up, down, and that's always opposite of what you think, so right, by K, and left by K. So again, they have this in the textbook. It's kind of a nice summary. You could even go like this. And you could say, if A is greater than 1, it's narrow. If A is less than 1, well, between 0 and 1, then it's wide. You'd even summarize 18.1 a little bit in there. So here's some practice problems for you. 5y equals x squared plus 2, and I asked you, I sketch it and identify the vertex. Okay. So what does this plus 2 mean? That means it's going to go up 2. Okay, so I'm going to sketch it, and it can just be a sketch, you don't have to make it perfect. Okay, then it said identify the vertex. So the vertex would be, the x didn't move, it's still on 0, and the y is now 2. Okay, what about this one? So I'm going to move left 3. My vertex is going to be 3, 0. My x changed. Okay, here's a little bit harder. Kind of putting it all together. So now we need to think about this, and we need to think about this. So this part means that it goes right 2. But this part, because it's outside of the parentheses, means it goes down 3. So it's a combination of those two. So right 2, down 3. So the vertex would be over 2, down 3, 2, negative 3. Notice right here that there's 2, negative 3 here, and notice where it is in the formula. That brings us to vertex form. Okay, so I'm going to kind of erase this for a second. So let's not think about up and down. Let's just think about the vertex. So there's a form, and I'm going to follow this same thing here. And sometimes there's a number out here, so we're going to call it A. X minus, they call this H, and they call the one behind K. And so they say this is H, K. So what this is getting at is that if you can get the formula or the function in this form, then you automatically know what the vertex is without having to graph it or anything. Because whatever number is here and here is whatever the vertex is. Okay? This actually, sorry about that, is plus in the form. Because this was a negative 3 right here. The K was actually negative, and so that made that, it was originally positive and it made it negative. I'll talk about that on the next page. I didn't mean to make one so difficult there. So I'm going to write the form up here, vertex form. And this is, again, one of those things you probably want to memorize. Okay, so I wrote the form up there, and let's say I give you this this function, and I ask you what happens to it and what's a vertex. Like, explain it. Where's it slide? Things like that. Where's a vertex? Okay, so this right here tells me that it is narrow, right? And also, it also tells me that it opens down. Remember when we talked about how if the number in front of the x squared is negative, then it opens down. If it's positive, it opens up. So that number tells me two things. It tells me how wide it is and which direction it opens. This number right here tells me that it goes left 5 units. And this number tells me that it goes down 3 units. Okay, so this is where it gets kind of tricky. Look at this as a positive, but in the actual formula, it's minus h. So that means if I had to name my vertex is actually -5. Oops. XH down left. Which way am I going? So then this right here is actually negative, but in the actual formula it's positive. So that tells me that the vertex is -3. If that is totally confusing you, you can also figure out the vertex from here and not make those mistakes of positive negatives. Okay? Because if you know it goes left 5, you know the x is -5. If you know it goes down 3, you know the vertex is -3 on the y. So you can do it that way too. But it's quick to do it if you understand how the formula works and how there's always a minus here. So if your number is positive, then you know that the original number that you slid in was negative. So let me explain that a little bit more. And again, if you don't get this, you can always visualize where it's going, okay? And I think that maybe doing it this way is going to make a little bit more sense. You know how the formula has an h right here? I'm going to go ahead and put an h right there, okay? And squared plus k. Okay? So these numbers, this number right here was a +5. So that means that this h right here, to make this say x plus 5, that h must be negative, because taking away a -5 is the same as adding it. Okay, and the same thing happens with the k. If the formula was plus, but in my equation it was a -3, that means k must be -3. Because adding a negative is the same as subtracting. And again, if that is too confusing, you can read inside the book and it explains it there too. But also you can always do it from here. Make yourself go through the whole formula or through the whole function, naming what's happening, and then you'll know the vertex because you can visualize it. Left and right is your x, up and down is your y. Okay, now sometimes you'll get equations that look like this, and they're not in any form. And they'll ask you to write it. The directions will say, write in vertex form, or in, vertex form. So remember, vertex form is y equals a x minus b squared plus k. So they want you to write it in that form. Well, that equation's not in that form. But what you can do is you know how to find a vertex. You know that, oops, that doesn't look like an h, did it? H. Okay. You know that h and k are part of the vertex. So you learned previously that you could find the vertex by using -b/2a. So I can go x equals -6/2 times 3. So that's -6/6, which is -1. So I know x equals -1. So I know this one is -1. Then I can plug the x back in to get y. So y equals 3 -1 squared plus 6. And again, this is just from 18.1. All the stuff that you learned there. So I can go in here and put -2. Okay, so now this is my h, and this is my k. So I'm going to put it into this formula. So I'm going to erase where I wrote h, and I'm going to put what I know h is a -1, and I'm going to erase where I put k, and I'm going to put what I know k is, which is -2. But think about that, that's not simplified. This right here, subtracting a -1 is the same as +1, and adding a -2 is the same as -2. So you have to simplify it all the way. So, oh, and then I know that my 3 is right there. So if I had to describe it, it gets narrower. The vertex is -1, -2. Okay, so it slid left 1 and down 2. So let's try another one. So if you add y equals x squared minus 6x minus 1, and again, you want to put it in the form, in vertex form, so I'm going to write it up here so I don't forget it. The more you force yourself to write it, the closer you'll come to memorizing it. Use it a lot later on, so not so much in this class. I'm going to use a little bit, but use it a lot later on in the math career. So I'm going to, because this is in quadratic form, it's not in this form, I need to find the vertex first. So x equals -b over 2a, which you probably have that memorized. I've said it a million times now. If I have -6 over 2 times 1, that's 6 over 2, and that's 3, so I get x equals 3. So I know this is 3. And I plug that back in, and I have 3 squared minus 6 times 3 minus 1, and I solve all that, and I get -10. So I know this is -10. Okay, so now I'm going to plug it in to right here and right here. So y equals, the a is 1 because there's no other leading coefficient out there, so I don't need that. I have x minus h, and h ends up being a +3, so I can just go -3 squared, plus k. K is a -10, and I'm adding a negative. So adding a negative is just subtracting. So there's my answer. And the book tells you, oh, you can do this in a graphing calculator and watch what happens and move things around. Well, you don't get the graphing calculator for 79, or for 70, what is it, 7060. So you can use it to find out what's happening, but you can't bring a graphing calculator to the final. Okay, and the last one, I'll do one more, and then I'll get this video online for you, in case people are wanting to do that today. And if this is totally confusing, it might be worth watching it a few times or watching it in chunks. So I'm going to find my vertex. That's -b over 2a. Oops, should probably write my formula up here. Okay. So I have x equals -4 over 2 times 2, which is 4, which is -1. So I have x equals -1. If I plug that in, and if I'm going too fast, you can pause the video while you're doing that. I'm skipping some steps here just because I know that class is going to start, kids are going to start coming in. So I don't have to worry about a dog, it's kids this time. So my ordered pairs are -1 and -3. Remember, that's my h and my k. So I'm going to slide these in to the h and k. So y equals, I have 2 as my a because it's right here. Okay. X minus h. So if I'm subtracting a negative, that's going to turn to plus. It's okay. If that's confusing, write it like this to start with. And then when you go to rewrite it, you can write plus 1. Okay, and then you got the k, which k is a negative 2, so you can write plus negative 3, and then write minus 3. So if you're totally confused about sliding those in and how signs are changing, then do it this way, then write it that way. All right? So 18.2 is a little tough, and hang in there. If you struggle or want me to explain something more, and send me a text, or I'll try to read my email all week, every day.